What we're going to do in this session is examine how we can use NLogit or Limdep software to evaluate data envelopment analysis. The first thing we're going to do is look at the Excel file that we have of data. I'm going to open this Excel file with some toy data in, data that I've just made up for the purposes of conducting this example exercise. And we've got 4 columns worth of data in here. The first one is labelled DMU, which stands for Decision Making Unit, and that's just an index of the various producers that we've got in our data set. So these may be separate banks, or they may be different firms, different producers of some kind. We've got 2 factors of production that they use, labour and machines, or labour and capital, and I've made up some values to go in there. Of course, you'll be using data from BankScope or some real-world data rather than made-up data. And I've got one output, sales revenue, which I've put in this column. Now, unfortunately, Limdep won't read data files that are in Excel format, so we need to convert this file first into an Excel format so that the software can read it. So I'm going to click out of this and click into some useful software that should be preloaded onto the machines in your lab. This is called Stat Transfer. And if I double click into this box comes up with input file type. There's a drop down menu. I choose Excel and I can browse to get to the file that I want to convert and double click on it to put it into this box here. In the lower part of this box, I choose Limdep as the output file type, and a default destination file will come up in the file specification here. I can accept that. It will just appear in the same directory as the input file. And so I click on transfer. That transfers it, and you can see that the destination file appears here, in this case on my desktop. Click out of Stat Transfer to exit. I can then double click on the data to open NLogit, or Limdep as it's also known, and I just need to click into this here and the NLogit window appears on the screen. I go to File, Open, and then I open the Limdep data file, and that produces a little plus in this box next to variables. If I click on that, you can see DMU, labour, machines and sales have come across. If I go into project and go into the data editor, you can see the data have been read into Limdep. So that's good news. The first stage is complete. I've read the data into Limdep successfully. The next thing I need to do is create a program file, and to do this I click on Start and go into WordPad, which is under Accessories and WordPad. That opens a document editor into which I type the Limdep code that I need in order to solve the problem. And I'm going to type a couple of lines of code here. The first word has to be frontier, and that brings about a frontier analysis. And then I want on the left hand side the inputs, the outputs that I'm going to be using. And the outputs that I've got in this case is just sales. Just one variable there. If there were 2 variables, I could separate them using commas. On the right hand side, I put the input variables, and in this case it's labour and machines. So 2 input variables, and I separate these bits of the line using the semicolon. I want initially to look at a constant returns to scale model, so I type in CRS, and I want to list the results. I want to list the efficiency scores that come out of this exercise, so I type in list, and I use an algorithm DEA, and I finish the line with a $sign. I'll then repeat this going to another line, exactly the same command, with the exception that I don't use the CRS qualifier. That means that it will give me by default a variable returns to scale, or a Barnes, Cooper and Rhodes, Barnes, Chance and Cooper, BCC variant of the data envelopment analysis model. I will use list, and of course I need to tell it to use the DEA algorithm. If I now save this WordPad, save it as, and I'll save it as DEA example for Limdep. And I'll use the suffix .lim, and I will save that onto my desktop for convenience. And there it is, it's appeared here. If I then drag this into the Limdep window and drop it there, and then click on Run, and I run the file. I need to open it. And the results come out in this output file. So at the top of the output file, we've got the CRS, the Chance Cooper and Rhodes CCR model, and we get the efficiencies appearing here for each of the DMUs, 1, 2, 3, 4, 5. And you'll see it's given us input-oriented efficiencies and output-oriented efficiencies. In the case of the constant returns to scale model of DEA, these are always the same as each other. So the figures that we get in this column should be the same as the figures we get in that column. That's not the case for a variable returns to scale model. Next, we've got the variable returns to scale model. The default is VRS or the BCC model. And here you can see again we've got input orientation and output orientation. The numbers here differ across these two columns in this case, but you can see that we've got more DMUs that are efficient according to the variable returns to scale model. So that gives a brief introduction to frontier analysis using data envelopment analysis in Limdep. There are some twiddles to this. You can use the Limdep software to estimate Malmquist indices, for example, and that is particularly useful if you have data for your banks or for your producers at various points in time and you want to compare how efficiency varies across those years in your data sample. That can be achieved just by putting another subcommand into the frontier command, telling the software how many periods you have. And you can find out about that by searching for data envelopment analysis Limdep in Google and finding the documentation for that. Hopefully, though, this has given you an easy introduction into how to use data envelopment analysis at a simple level within Limdep software.